We've got a graph that's representing a real life situation. In this price, the cost in pounds, so this is the cost in pounds. Can I recommend, if they don't tell you what the axes are worth, you write it down. So this represents cost in pounds against the minutes. Okay, so let's have a look. Write down the equation of the line. Well, it's a line, so it's y equals mx plus c. Remember that m is the steepness or the gradient, and c is the y-intercept, where it crosses the y-axis. Well, I can see where it crosses the y-axis. It crosses the y-axis just there. So that must mean that my y-intercept is 3. Well, that's easy enough, plus 3. But I need my gradient. Remember, the gradient means for every 1 you go across, how many do you go up? Obviously, it needs to be better than that because that was a horrific picture. Now, in this case, it goes up less than 1, so it's not very clear. So it's more useful to go up a couple of times, if you remember, until you hit an actual coordinate point there. So I could go there, or I could go all the way to the end if I wanted. It doesn't really matter. And then I look at the change in y divided by the change in x. Okay, so if I were to take the end point here, my change in x, how many have I gone across to get there? Well, I've gone across 10. So my change in x is 10. And what's my change in y? How many have I gone up? Well, I've gone up 5. So my gradient is 5 over 10, which is a half. And you can see that because every time you go along 1, you go up half a square. So the gradient is 1/2. So I've got that y equals a half of x plus 3. So I could either write a half like this or 0.5. Normally I would write it like a fraction, but because we're talking about a real life situation, a decimal is quite useful. I've now written the equation of the line. I now have to give an interpretation of the intercept, which can feel a bit disconcerting, a little uncertain, but it's not too bad. They're quite similar each time. So my intercept is this point 3. What does the 3 represent? Well, if I look at the y-axis, it's the cost in pounds. So it's £3, but what does £3 represent? It's how much I pay if I don't go anywhere. So if I get in the taxi, it's how much is already on the meter, £3. So it's the fixed charge. So it's a £3 fixed charge. Okay, and what about the gradient? Well, the gradient, remember, is every time I go across 1, how many go up? Well, if I go across 1 minute, how much is it costing me? 0.5. 0.5 pounds, 50p. So it cost me 50p per minute. Cost me 50p per minute in my taxi. Okay.